morning, everyone. We are going to wait a couple minutes to everyone else join to the class. All right, I guess we can begin. Welcome, everybody. Today, we are going to have a tutorial session. I'm going to show you how to develop a user graphical interface using the Matlab App Designer, and also how to make the web deployment using the Matlab Web App Server for your final project, your digital twin application. As example or study case, I'm going to use the same DC motor system digital twin that we have been working during the last 3 labs. So the idea is we are going to close the cycle, and you can see what we expect about what we can expect about this digital twin implementation. Before beginning, please, if you can ask this poll, will be really good, really useful. Is about if you ever work with user graphical interface on your. Okay. Okay, just wait a minute. That finishes all the answers. All right, let's stop the pool. Let me share the results with all of you. I noticed that half of you said that never made user interface before. The other 40% said yes, and some of you noticed using Matlab Guide or Matlab App Designer, another Python. So I guess that's the situation right now. So no worries. We are going to cover like a basic sample first of using graphical interface, and then we're going to jump into the web app design, into the digital twin deployment itself. All right. So let me share my screen. That's it. Okay, so let me increase my screen. All right. So before beginning, I just want to notice to you what are the tools that we need in order to develop the digital twin, to make the deployment with the GUI and make the deployment with the web app server. First of all, we need to have MATLAB 2020 or MATLAB 2021. Because the web app server with compatibility for Simulink applications begin only from MATLAB 2020. So please install the most recent version of MATLAB. In both MATLABs should work. I'm running MATLAB 2021 right now and it's working. However, if you have an older version, I had the 2019, doesn't work really well for me. So please install the most recent one. You need to have also installed, in addition to this, MATLAB runtime, MATLAB compiler, and Simulink compiler. In this case, I here said only for MATLAB from MATLAB 2020. Those tools, especially the Simulink compiler, in particular the Simulink compiler, appears for first time on MATLAB 2020. So that's one of the reasons why we need to have the last version of MATLAB. Install the web app server. This is another thing that we need. On CAT courses, you will find a tutorial step-by-step how to install these softwares, all these tools. I can open the tutorial for you. Okay, I can show you the tutorial. This tutorial is in the CAT courses. Let me show you where it's located. Okay, this is CAT courses. If we go to course files, and then we go to lab, final project, GUI and web app server tutorials, you will find the tutorial over here. You will find this tutorial step by step. This tutorial is in order that you can install those tools list here. They're MATLAB runtime, MATLAB compiler, and Simulink compiler. Something important is that if you install the full MATLAB, for sure you will have the MATLAB compiler and the Simulink compiler already installed, so you don't have to install it. You just need to install the MATLAB runtime. This runtime is a tool that allows MATLAB it's like a set of libraries that allow running MATLAB libraries and programs without the need of having MATLAB installed in the computer. So this runtime will be useful for the web deployment. It's required for the web deployment. That's the reason why we need to install it. Okay, those are like some of the prerequisites. Follow this guide, install the prerequisites, and get the last one of these two last version of Matlab. That's the thing. All right. So let me start with some basic GUI. I noticed that some of you don't have any experience dealing with graphical user applications. So let's start with something really simple. Okay, let me share. Let me show you here. Can you see my screen? Can you see my screen, guys? Okay. So first of all, Matlab has two ways to build user graphical interface or GUI. One is the environment guide, and the other one is the app designer. We're going to use the app designer because it's the one compatible with the web deployment. If you want to access the app designer, you came here to Matlab, and in the command window, you are going to type app designer. You are going to type this command, app designer. My case is open. This is the example that I'm going to show you. This is the study case that I'm going to show you later. However, let me start with some blank GUI or blank application. Once you start your app designer, you will have this canvas. You have these components here, and you have some component browser. Essentially, the main idea when you develop a user graphical interface is that you, through some buttons or some controls, let's call controls any interactive element that let you select some data or choose some options for executing your program. You are going to do through a graphical interface. This type of programming is quite different from, it's quite different in the sense that this is called event-based programming, because when you have a user graphical interface, you perform an action once some event happened on that graphical environment. Usually the most simple event is when you click a button. That's an event. And if you click that button, of course, you are going to produce some, you want that button execute some code. That will be the main idea. So let me show you an example first. I want to show you something really simple in order that you can get the idea, and then we are going scaling. We have many different controls and elements here on the left side, as you can see here. We have this axis that is a plot, like Matlab plot command. You can make a graph. Checkbox, button, date picker if you have some calendar application, edit fields where you put information, labels or text, radio buttons, tables, spinners, images, text area, toggle button, tree. This tree is like a folder tree. Some containers, figure tools. We can have some additional instrumentation like knobs, switch, gauge, linear gauge, circular 90 degrees, LED indicator, some aerospace controls. if you want to do something like clean inclination or artificial horizontal or turn coordinator. It depends on your application. For our case, we're going to focus only on these basic controls. I'm going to put first this control, this label. If you want a control on your canvas, you just drag the control over the canvas. Let me drag this numeric field. Let me drag this one here. I'm going to drag two of these controls. What else we can put? Just let me show you some of the other controls. This is the radio button. I'm pretty sure you saw this set of options in multiple Windows applications. Basically, you can choose which, this is a selection mechanism to choose between different options. In this case, let me show you another one. This is a slider. For example, if you do some volume control, you slide through some range between 0 and 100, or depending of your application. I'm pretty sure you also saw this one, the spinner, that you can increase or decrease in a certain amount, some value inside this box. So I'm pretty sure you saw this control before. And in this case, the most important one, the button, which is the one that we push and we produce some action or some event. If you want to import an image, you can do it here also. This is an image, this is a control for image. You can also do it. Okay. If you want to group some elements, you can use these panels. Let's say this here, and let's set this here. We can group using panels. It make much sense because you can organize everything between subgroups, and those subgroups will help you to keep your code clean or your interface clean for the users. So this could be one example. Let me show you here. This component browser basically is a list of all the components that you have on your user interface. This is the name of the app at this moment, app 1, because we are not saving the app yet. We see this app.ui figure corresponds to this canvas that we have over here, and so on. For example, if we set app.panel, we can see here that this panel, that is this one here, group these edit controls that we have. Okay, yeah, and so on. You will see all the controls here. The button group with all the radio buttons inside here. The label and also the button should be over here. Yeah. Okay, I'm going to modify this label. When you select any component, you will see the properties of the component in this below this component browser. You can modify the text here. Let's set first GUI example. You can edit the text properties, italics, bold, size. I'm going to increase the size. This case, similar here. You can put a name for this edit field, something that is related with the parameter or the use of this edit field. Let's set A here. Let's set B. Let's set A and B. Okay. Okay, let me drop another one really quick. Let me drop another edit control. Okay, something important here is that let's set ABC. Something important is that we have two types of edit fields, one for text and another one for numeric. In our case, most of our fields will be numeric. So this will be the control that we are going to use the most. Okay, let me put this button here. You can double click over the control and change the name. For example, let's set here, let's set the word run. This program is pretty simple. I mean, I just want to explain how user interface work and what will be the main idea. And based on this main idea, you can start working on the next steps, more complicated. So we have a value A, we have a value B. We're going to perform just the summation of A plus B. That's what we're going to do right now. Just to explain you how the GUI works. Let's do it this way. All right. So when we have event-based programming, the main important thing is that whatever action that we are going to do over the GUI, we have to do some action over the GUI, or we have to generate some change in order to produce a response of the program. In this case, the simple event will be when we just click over the run button. That will be our event that trigger, in this case, the summation of A plus B. So we have the edit controls. We have here run. As if you see here, I changed the names. You see that here the names change. A, B, C. In this case, has the edit field termination. You can modify the name if you want, but for now, just let's keep in this way. We can set that this is called just C. We can set that this is just B, and we can set that this is just A. We can customize our names. If we customize directly from the component browser, we'll change for everything. So, okay. When we want to, now, if we want to add the event to the button, in this case, to the button run, we may right click over the button and we set here callback and set add button push function callback. This callback basically is when I push the button, I'm going to execute some action. That's the function of the callback. So let's do it this way. When I create a callback, I open the code view of the user graphical interface. In this case, this is the, oh, sorry, let me fix this typo here. Okay. We have two views for this app designer. One is the canvas, when we see all the graphical elements. And the other one is the code view, where we are going to edit or make the codes to run, to execute some function or trigger that event. So right now, let's go do it again, callback. In this case, the callback opened this run button push. This will be the function that will be executed once we click the button. All right, so let's set something like this. I'm going to create a variable called A, a variable called B, and a variable called C. In this variable, A, I'm going to set that I want the value stored in this box, and for B, the value stored in this box. And Z will be the summation of A plus B, and I'm going to put the result over this box. That's what we are going to do once we push run. So A will be, in this case, I want to access to box A value. So we set app.a.value. What we are going to do here is we're going to put in variable A the value of this box that we have here. We can do exactly the same for B, app.b.value. We can set that A plus B is equal to Z. And then we can set that Z is that now that we have C, we want to put this value of C on this box. That's what we want to do. So app.c.value will be equal to Z. You see, everything in this application is related through this app object, which is essentially that we have from here. So all the objects and all the controls are related through this object. So most of the things that we're going to do will be related in this sense. So A, B, A plus B, Z, and then we put the value over the control. Let's keep simple for now. We're going scaling as we go through the tutorial. Let's run. I'm going to save this application, simple app. I'm just save it. Simple app is loading. Could take some time. I have multiple things open at this moment right now. Okay, I guess it's, yeah, I guess it should be loading. Yeah, it's compiling. I don't know why it's taking so long. Shouldn't be that long. Okay, now it's open. You see, I don't know why it takes so long. Maybe because I have many things open at this moment, but we have the panel, we have the slide. I mean, right now we are not using these controls below. This slider we are not using. We are not configuring the spinner or even these group buttons here. We're just focused on this panel. However, everything that you put, you will be able to see over the canvas. Okay. Let's set, for example, 10. Let's set 10. Let's set 12. Let's click run. We perform the summation. And that when I click that button, that represents the event. Take this in mind when you make GUI in any language. This is a general rule. You want to produce some event that triggers some response. In this case, the event is this one. If I change the value to 1, this changes, or if I make this change also, it's going to work. This event is the most important part. We program the button to produce some action based on the information that we have on the controls. That will be the example in this case for GUI elements. Okay. We can keep doing events and dealing with these different applications the whole day. However, I guess you can explore as much controls as you want. Just let me show you. I'm going to use the slider in addition to this button. Okay, just let's put this one. I'm going to extend the panel. I'm going to show you the slider. In this case, the slider, you can set up the default value where it starts. I'm going to set 50. Limits will be 0 to 100, but you can customize the limits. Same for all the other controls. If I choose the spinner, for example, you can set up the limits of the spinner and the amount of the step. All the properties are, you can edit all the properties from here, so no worries about that. All right, I'm going to do something different with the slider. Essentially, what I want is that if I move the slider, I'm going to have another edit control here. Let's call this K. I'm going to call this control K. You see that now the K control is created. I'm just going to modify the name just to make things clear. What I want in this case is that if I move the slider, the value that appears in K should be the same of the slider. So in case of a slider, is one of those events that as I move the slider, I want that the value changes on this box here. So we could come here, we can set we have like different types of callbacks. Value change, value changing. Let's use the first one, value change. For each event that you want to program, you will have one different callback. So in this case, we have value, app, slider value. You see, it's the same method that we used before, app, the name of the control, and in this case, value. And by default, Matlab saves the value of the slider in this variable called value. Now I'm going to set like app.k.value will be equal to value. Why value? This value here. So I'm going to execute again the interface. Okay, something happened. Let me verify. Just let me check. Okay, I guess my app is okay. Let me run again. Let me verify if this first event works properly. Okay, let's do something. I'm going to restart the app designer right now. I guess I have multiple things open at this moment. I'm just going to close and restart my Matlab GUI. Just let me. I don't know what's happening. Oh, okay. Okay. I'm just restarting my Matlab. Sorry about that. Not many things opens at this moment. Okay, Matlab is reopened. Let me open again the app designer. Okay, this is the start page. I'm going to open the same app that we was doing before. Okay, let's wait that load. Let's run again. Right, let's see. 10-1. Okay. Okay, we have an error here using Matlab edit set value. I think I know what is the problem. Maybe this is the problem. We need is this one. Let's run again. Okay, yes. Maybe take the ground control. I'm going to take, in this case, a numeric again. Let's set K. Right, let's do it. App.k. Let's see if you can solve it. Yeah, the error was that I was using this edit field text. So what this box was expecting before was a string, not not a numeric value. So that's the reason why it wasn't working. So right now, as you can see, if I move the slider, based on this event, I'm changing the value here. However, if you, let me just make an example. If I change this value, this event is not related at this moment with this event. Therefore, you can have, let's say, like parallel events on your user graphical interface. So this button performs one action and this slider is performing another one. So your events can be independent on your GUI. And this is something really useful because we don't want that everything is related just to one button in many cases. We need different events running on the same GUI. And this is one of the good things about graphical interface. You can have independent events running at every moment. Okay. Any questions at this moment about the user graphical interface? Okay, I guess no for now. So that's the basic idea. I could keep doing more and more examples about the using of GUI. However, based on this tutorial, you can explore more and use other controls like these radio buttons, the spinner, or any other of the that we have here. Okay, this is one example. Let me open. Let me open another one that I already made before. I'm going to run the function in order to let you know how this works. Basically, this spinner controls the amplitude of this function. This is the source function of Matlab. We are controlling the amplitude of the function using the spinner, but we are doing a plot. This is one of the things that we need for our projects. Make some plots. So let me go back here. This GUI is pretty simple. Only have this chart with the plot and this amplitude here. So if we come here, basically what we do here is we create a callback for the slider, similar thing that we made before on the previous example. We take the value, then we use the plot command. However, I want to be a little bit more specific about this plot command. Usually when we do plot in Matlab, it's essentially the same plot here. However, here we need to specify which plot we want to, in which plot we want to draw the figure that we are doing. Let's say in this case we have only this plot. However, the idea of GUI is that you can have multiple plots at the same time. Therefore, you have to refer to your plot in the same way as other variables or other elements. Your plot will have an object here. You see, app UI access. Every object that you put here in the canvas will have this object identifier here on the browser. So this value plot will be here. You can see here app UI access is the first one, which plot we want. And then in this case, the y-axis that we are using. If we have an x-axis like time, we just add first the time here and then the y-axis. And if we have z-axis, it's the same syntax of the 3D plot 3D. The only difference, we need to introduce here the identifier of which plot we want to plot. Same properties like app, UI access, ylim, xlim, xlabel, ylabel, title, legend, all those commands, you can use it directly here. So you see that many of the comments that will have been learned during the semester are exactly reflected here. So we just have to consider like this, have these considerations in mind when we do the web application. All the other MATLAB commands, libraries, and everything that you have, you can call directly from here. So this is another advantage of GUI in this case, is we can use all the same MATLAB language. Okay, this example is some graphic example. Yes, yeah. This is some graphic example. We're going to do more about graph with the GUI example, with the digital twin example, so no worries at this moment. This part is just to introduce you how to operate this GUI interface. Okay. So first of all, now that you get an idea about what is GUI and how you can work, let's go with the digital twin. I'm going to use the same DC motor system that we have been using up to this point in order to close the loop finally and perform the digital twin deployment of the application. Let me go here, open, going to open the, want to open in this case. Should be this one. Yeah, it's this one here. If you see the GUI, in this case, has most of the elements that we want or we expect on the final digital twin deployment over the web app server. You see if you see all these parameters are the ones that define the nature of the motor, the mechanical, the first one, and the electrical, the first one, and the mechanical, the other ones. By default, in this case, we have like several boxes with all the values of the parameters for performing the simulation. This is the closed loop block for the application that we said on the project description. Something like this. This is an image. Basically, you can browse which image you want. If you drag the image control, you can search for the image you want. That's the main idea here. We have 3 plots. In this case, these 3 plots correspond to time response, control action, and error signal. Those are the plots that we need for this system itself. Right now, I'm doing only the closed loop part. However, you have to be, your system should be able to see the open loop and the closed loop behavior. I'm doing only in this case, the closed loop to simplify the design in this case, but you will see that at the open loop is not really difficult. Input, in this case, I'm using only one input, that is the step. It's not code the impulse and the sine wave, but again, you can see it. You can explore how to do this. This is the digital twin. Okay. Velocity control digital twin. This is from the control digit. This is from the app point of view that the user is going to see. This is the front end, basically. The back end behind this is here. I will explain you all these comments in a minute. But first, I want to go in this case for the digital twin. I want to go in this case for the digital twin. It's loading. Okay, if you see this if you see this Simulink Simscape diagram, it's exactly the same diagram that we have been using for Lab 8 and 9. We have the electrical part, we have the mechanical part of the motor. In this case, we have the PID controller. I'm using exactly the same diagram that I provide you for previous lab. I have to make some differences in the way that we are coding this application. All these differences is because the web deployment has some specific characteristics that we have to follow and respect if we want to deploy our application on a web server, considering that we are not going to have directly access to Simulink through the web server. So some things we have to be, just to be careful. I'm going to provide you this model and the sample of the GUI. However, it's important that you pay attention to the details because each system is different and each system will have relevant features or characteristics that you have to incorporate. First of all, let's go here to the configuration panel. Okay, in this case, this is a fixed step simulation, 0.1 seconds. This is important. We made information logging before using from workspace and to workspace blocks, which is okay. That works perfectly. However, for GUI design, we cannot use from workspace and to workspace. We have to do in a different way. That way is that we basically centralize all the information into one array or structure with time. That output in this case I call Y, and this simple simulation output, okay, this is out. However, the most important part is that all the information is centralized. All the information done in and out is centralized here. Using a structure with time, we ensure that we have a time vector and we have all the vectors related to the system inputs and outputs. This is something important. Okay. Before using the from workspace and to workspace block, we put one to workspace here, and we, using a MUX, we connect all the signals that we want to log to the workspace. In this case, because we need to do the web application, what we're going to do is we're going to use this. You remember this output, this out block that we use for the behavioral matching on the previous lab? We're going to use these out blocks to log the signals that we want from the system. In this case, will be the reference. In this case, this reference is 500 RPMs. We put this into an output block called R. E is the error signal. U is the control action. Really important and necessary to analyze into a closed loop system. And here the system output itself. That will be the velocity in RPMs. So you see that it's just a difference between previous one. On the previous labs we use from workspace. In this case, we're using this way to log the information. But no worries, this is just to make compatible with the web design. So any variable that you want to log, you have to do in this way, using this output here and this output block to log the information and configure here the output of the data output. The rest of the block is the same. Okay, something important that you have to have in mind when we do these applications. This is a block that we didn't use before, memory. This block memory, think in the way that is like an initial condition block for beginning any calculation. Yeah, this is basically an initial condition. Let's keep it that way. We're using this as initial condition. We need this memory block in our digital twin application for the web deployment because Simulink itself is a ODE solver. If we look in the beneath all this graphical layer, is an ODE solver. According to the ODE solver that you use, the solvers sometimes assume initial conditions to satisfy something that is called algebraic loops. Algebraic loops because Simulink doesn't know which is the initial condition and is going to start, and basically Simulink by default set the initial condition is 0. That's what Simulink does. However, because we want to perform this into the web application, the solver for web app is not able to assume that initial conditions. So that produces an algebraic loop. In a regular Simulink execution, we don't have any such problems. But here, when we want to make web deployment, we will have that issue. So for any feedback loop that you make on your loops, on your control loops, when you are developing your digital twin, and specifically once you are getting ready for web deployment, for any feedback loop, you have to include this memory just to make the solver able to solve your system. This is something that could look pretty strange at this moment, but trust me that that gave us a lot of headache in the past. So keep that in mind. Okay, let me double click now the Simscape. You see that all the parameters in this case are related with a variable, resistance, inductance, EMF, as well as the rotor inertia. Okay. So if you check the parameters, we are relating to a variable. However, in the top left, we can see this compile time control. Compile time or runtime. Let's going to define all that are not blocked as runtime. Why we do this thing? Simple. Because when we say compile time, Simulink what we are going to do in this case for the web deployment is that Simulink generates some C code that is like directly from the Simulink block diagram. That's what it's going to do. If we want to enable the possibility to change some of the parameters as we run the simulation, or we execute the digital twin on the web server, or even inside Matlab or Simulink, we need to define these parameters configured in runtime. This gave us a chance to change the parameters in the middle of the simulation. Consider that not all the parameters we are able to do that. Some of them are blocked, like the armature inductance, or in this case, the inertia and damping. When we set compile time, it's basically that this value, when we generate the code, is hard code and we cannot modify it. This is something that we have to keep in mind. So every time you use the Scenescape on your digital twins, just put these variables as runtime, doing this way for all that are available, because that will allow us to make some modifications in the future. So keep that in mind, runtime. Okay, let me check here. I guess here we are not changing anything. Same here. Yeah, I think this is some important details that you have to keep in mind when you build this Simulink block. Another important detail is that the web application is going to run in this rapid accelerator mode. It's rapid accelerator because Simulink first compiles the block diagram that we have and produce a C code and execute that C code. That's the reason why it's called rapid accelerator. And your Simulink model is going to run into rapid accelerator in the web server. So if you, once you are ready for your deployment, just set up as rapid accelerator your simulation diagram here. For the first step, in order to verify that your system dynamics and your simulation make sense, just do in the way that you do your simulations, or the regular way for Simulink. All these, let's say, tricks are once you are ready for deploy the system into the web server. So that's like the main idea. Right now we are following all the knowledge that we have from before. This model, we are going to provide you with this model as well as the user interface, so no worries about that. Okay. Now that we made that we customize the digital twin in this case, let's go here to the interface. In this interface, basically, we define or set the parameters of the motor, the electrical and the mechanical. We define the constants for the PID controller. Okay, I guess I missed this part. KP, KI, KD. Those are the constants for the PID controller, are related to those variables. Okay, let me just increase a little bit this length. Same here, just increase the length a little bit. Yeah, that's it. The terms of the PID are really small, so we need some in this case more space to display it. Okay. In this case, the main event will be the run button that basically is going to execute the simulation and show us the response of the digital twin. Callback. We create a callback, similar as we made before. Right click on the button, callback. Here we have some new commands. I'm going to explain you the commands in order that you can understand what we are going to do right now. First of all, we're going to clear the charts. We don't want the previous information keep over there. Okay. Because we can use these commands to make Simulink block diagrams run. We can run the Simulink from, one of the first things is that we can run the Simulink from in this case, from the script of the app designer. This is one of the main things first. To make that possible, we have to create an object. In this case, this object is called simimp. You can put the name that you want. I'm just using this one. I'm just using this one as default, let's say. This object basically is going to capture all the information of your simulation, of your Simulink block diagram simulation at all. First of all, in this object, we are going to include the simulation for the model that we want. In this case, the model is DC motor Lab10 DT. This is the model that we have. And we are going to include the whole block diagram inside this sim input. Once we create the object and we link the Simulink file, the next step is define the parameters that are inside this Simulink block diagram. If you see here, we have the parameters of the motor and we have the parameters of the PID controller. So how we do this link? In this way. Remember, we create this simp object. So everything that we're going to do is we're going to be linked to this object here, simimp. We're going to set simimp.setVariable. This method setVariable is going to create that variable in the workspace and is going to assign some value to that new variable that we are creating. In this case, let's say we're going to create a variable ET armature resistance, which is one of the parameters of the motor. And then the value that we want to assign to this variable is the value in this box, app.armatureinductanceEditField.value. If you want to check the name of any of these controls, you basically came here and you can see here the names. You see that if you use panels, you can group in this case the controls, and it's more clear when you are making your deployment. So I recommend you a lot that you use this type of panels when you do your simulation, when you build your user interface. And we are going to do exactly the same procedure for all the variables. Armature inductance, we take the value from the box. For the PID controller, we do exactly the same, and we take the control values from here. So we link our Simulink file, and we assign to all the variables in our simulation the values on the controls. Okay. I guess this is like the first part, link the file and assign the variable values. Okay. Now we need to use this command, Simulink compiler configure for deployment. When this command is to set to Simulink to a web app server or the web compiler that this application is going to be executed on the server. So it's saying that you have to compile using the Simulink compiler. This, of course, is going to take some time because this command is required to signaling that to Matlab. However, for your initial simulations, you can just simply comment this line and you verify that your GUI works properly. Okay, this is more for implementation on the server. Keep that in mind, but for your simulations and your testing, you can just comment this line. Okay, I think this is one of the most important parts. Once we define the variables, we set up the simulation, we clean the graphs. The next thing that we're going to do is we're going to simulate or run the Simulink model directly from here, from the user interface. So in order to do that, we're going to use the command sim, the same command that we use with the Matlab script. And in this case, we're going to run the sim object, this object that has all the simulation configuration. We do in this way, sim imp, and all the output of the this simulation we're going to save in this variable called simout. Simout equal to simp inp. Okay, so remember that we said that in our block diagram we save as structure with time everything in the array y. So now is where everything is going to make sense, because time is going to be in the variable simout. The variable simout has also the variable y, and the variable y has the value time. It has the value time. In the same way, we can do the same for the reference, the error signal, the control signal, and the output signal. Simout y signals. In this case, signals is the array that has all the outputs of the system. Dot values take all the vector that take all the vector of these signals here. That's the reason why we made those configuration before. We have here this plot. This plot here is just this plot over here, time response, control action, and error signal. As we said before, we link first in this case, we link first our specific chart that we want to plot. As you can see here, we have 3 plots. So we have to set which is the one that we want. Time response, the first one. Okay, let me just make some small change. I just want to make the reference in red and the response in blue. The hold on, we have exactly the same issue. We have to notice which plot we want to activate the hold on to keep storing the responses. So in this case, for time response, we set on because we want to plot the output of the system and the reference. Finally, here we have the other plots, the control action and the error signal. That will be from this side of this point of view, what we want in this case. So let me run execute the simulation. I just want to show you here. I have the parameters, I have the PID controller terms. Okay, let me just put this in 0 for now. It's going to take a little bit of time. Yeah, it's processing. Going to take a little bit. Okay, now it works. You see? If I made that change over my integral term, my response is faster, as you can see here. Something good about this, about using the app designer with newer versions of Matlab, is that you have incorporated the zoom and all the same tools that you could have with some regular simulation, with a regular plot, which is something good. This layout is what I did. I mean, layout, I mean with the distribution of the controls and charts. You can use your own. This is just the way that I do it, but you can customize according to your thinking. But basically, those should be the elements that should be contained. Okay. So we can modify some of those parameters also. It depends of what exactly you want. Now that we have this GUI application here, let's Any questions at this point? This will be like the first part at this moment. This is the first part about how to make the GUI and link with your Simulink file. This is the first part. Okay, now let's go. Okay, if there's no question at this moment, let's go for the second part. In this second part, what we're going to do is we are going to take this application in the way that is it right now, and we are going to compile this using the web compiler, and then we are going to upload this using the web app server. That will be the last step. So, all right. If you use the Matlab 2021 for, in this case, for deploying the application, something important is that we need to use this web compiler. This is one of the things. The other thing, this web compiler basically is going to compile the application into the web app server, generate the C code in order that the web server could execute it. But we are going to do this later in the process. Let me go here. Matlab should be anywhere here. Okay, here we have the Matlab Web App Server. It's opening. I want to open in order to show you what is this web app server that we talk about all this time. Okay, it's loading. Basically, what the web app server does is open the application to the internet. That is what the web app server is going to do. In this case, what we have to do is copy the app into this folder once it's compiled, and we launch the web app server here. We can define the port access number, timeout. This timeout is to log into the server, and timeout if someone is not using after 5 minutes finish the session, for example. This will be this web server is the one that is going to make the interface between our computer and the network. I'm conscious in this case that you need a static IP to run this. However, we can verify that everything works from our web browser locally without the need of any static IP. The static IP, we have one on the lab, and using that static IP is where we are going to upload all your applications in order that you can access to all of them. So let me show you here first. I want to explain a little bit of the tutorial for the installation, just to be sure. Okay. Right. Okay. The first one to step 1 to 4. Step 1 to 4 you can follow, but basically those steps, if you already installed the complete Matlab, those steps are related to that. One of the important things is that you have to, on the step 5, you have to come here and download the Matlab runtime, run compile Matlab applications or components without using Matlab. That's the reason why we need this runtime. It starts from 2017 to 2021. My case, I have the 2021, so I download the 2021. If you have Mac or Linux, you can download the runtime. It depends of the version of Matlab that you have. My case was this one. You download this. Let me go to my downloads folder. I can show you. Okay, no, it's not in the downloads folder. It's here. The runtime environment weight is about 4 gigs. So it takes some time. Then you have to extract that runtime and run the setup. That's what you have to do. And then this is the first step. You need this runtime. Without that runtime, you cannot execute and install the web app server. To install the web app server, if you install the complete Matlab, you came to this direction, to this directory. Of course, it depends on your Matlab. If this part is going to change, if it's 2020, 2021, you go to this direction. I'm going to do it right now for you. This C, program files, Matlab, 2021. Let me show you toolbox, compiler. It's quite long. Compiler, deploy, Win64, Matlab server, offline. You will find this WinZip, this compressed file. Inside this compressed file is the web app server installer. It's already included among all the dependencies of Matlab. So will be here. The direction is here. You can just follow and you will find that installer and you install the web app server. When I refer to web app server, I refer to this one here, the web app server. This is the one that I refer. So you have to follow this guide and you can configure without so much problem. But first install the runtime and then install the web app server. This is something that you need to install in addition to your Matlab installation at this moment. Okay, so being clear about that, let's follow the process. Now we have the GUI and the GUI is working. So now we want to compile this GUI and generate the compiled file that is compatible with the web app server. So you are going to come here to apps and you are going to search one toolbox called here in application deployment. You are going to search for this web app compiler. If you install, your Matlab license should have this web app compiler, and also you have to, you should have this inside your license. So that's why I suggest you to install the complete Matlab, because sometimes if we choose only some specific toolboxes, we can miss some elements. So if we have everything, it's better to have all together. So, okay. Now, first of all, we're going to generate the file to upload to our server. The first thing is we came here to add the application. In this case, the name of my application is app1. I put that name, app1. I'm going to open. I repeat again. I came here, I add the main file of the application, app1. Something important is that all the files that you need for your application should be in the same folder. It means your Simulink diagram, and in my case, the figure, in this case, the figure for the block diagram, the digital twin, and the application web and the app designer file all should be on the same folder. Okay, everything is here. We have the name. Let's keep the same name. We just came here and let's set, once we copy here, we click in package. Okay, I'm going to set yes. I already do it, but let's do it again. Now it's creating the web app. It takes some time. Okay, something happened. Let's check. I'm not really sure why I say that we have this problem. We don't have that problem before. Somehow it's not recognizing the PID. Somehow it's not recognizing the PID terms. I'm not really sure why. Okay. Okay, if that happens, we just create a variable called K, just create the variables KP, KI, and KD. I'm not really sure why it's not taking the variables. I just generate the variables by hand in the workspace. This is the type of things that could happen when we make the compilation. So no worries about that. Let's run again. Hopefully it works this time. Let me check. Okay, now it works, which is good. You can open the output folder. Because it's opening the folder. Just wait a minute. Okay. I can show you the folder. Okay, now it responds. Now it responds. So this is where I have all my files. This is the app1 folder. In the app1 folder, you will see this these login folders. We don't need that one. The only file that we need is this one, app1ctf. What we have to do right now is copy this app1ctf into the web server. So how we do that? We came here to the web app server. We came here to open folder app. Okay, I have some other apps here. We just copy this app1.ctf inside this apps folder. You just came here to the web server, click here and copy this CTF file here. I'm going to start the web app server. In that sense, we're launching our web application. Now it's running. Let's set now go to home page. Okay, something happened. Okay, let me run again. And just copy all the files. Let me see if this is required. I'm not really sure. Let's do it again. Let's stop. I'm going to open the web server again. Sometimes it could be. Okay, I reopened. I'm going to relaunch the web app server. In theory, in this moment, we should be able to see the app1 as well as this other tutorial app CATF. Let's open again. Okay, somehow it's not recognizing. Oh. It's not recognizing my app1. Okay. Let's do something. Let's clear this one. Okay. I'm going to generate the app again. Okay, let me repeat the process. I don't know why the folder result corrupt. I just erase all the files on the root folder and okay. Let me create the app again. Okay. Theory should work, but I'm not sure. Okay, let's copy again the CTF file. Let's go to the app folder. Let's start the web server again. Let's go to the home page. For some reason, the app jumps corrupt. Okay, let's do something. I'm going to close. Let me close Matlab and open again. I'm not really sure why it's corrupt. The file is corrupt. Need to verify. Okay, let's open Matlab again. Going to erase everything. Let's check again. App file, app one. Okay, let's check the settings. Fine. Okay, that makes sense. Okay. Huh. Okay, let me open again the app designer. Not really sure why it's. Okay. Theory should work, but let's check. Okay, simulating. That's theory should work the simulation. Well, let me check. Okay. Wait a minute, please. Okay. Theory makes sense. Let me run again. Okay. Hmm. Hmm. Okay, now it works. Okay, I'm going to generate the application again. Okay. Okay, theory compiles again. I'm going to reopen the web server. Okay, let's start. Hmm. Okay, let me try something. The only thing that for sure I change. That's the only thing for sure I change. Didn't add anything else. Okay. Okay, let's run again. Okay, it's starting again. This part used to be really tricky, as you can see. I'm not really sure why it's generating a corrupted file. Everything should be in order. No. Let me check the Simulink file once. Yes, this part is fine. Okay. That could be part of the problem. Let's check again. Okay. Okay, I'm regenerating again. I'm trying to keep same state as before the tutorial. Without any major changes. Okay. I'm not really sure why it's generating a corrupted file. Was generating a correct one. I can show you. Let me show you the other one. Let me show you other of the apps. I'm not really sure why it's producing a corrupted file. I mean, this is the one that I showed you at the beginning. the tutorial one. This case is running directly on the browser without any additional intervention. However, I'm not really sure why it's producing this this corrupted file. Let me check. We're just following the same steps. Okay. Hmm. Hmm. I'm going to show you a previous version. It's not complete, but you can see the layout how it will be developed. In this case, this is an older version. It's not, in this case, it's not complete. But you can see that it's essentially the same interface. Let me check one more thing before continue. Let me just do something. Okay. Okay, I'm going to do something. In this case, okay, let me maybe that's the problem. Now I think I get the problem. I guess I was using an older version of Matlab Web App Server. I was using Matlab. I using an older version, but I need to be sure. I just want to be sure. Yeah, I think that was the problem. I was using an older version of. Yeah, now makes sense. If I start changing the value, if I start changing the parameters. Yes, this session will be recorded. It's recorded and will be shared with you. I am pretty conscious that this is a lot of information to get just in 3 hours. Um, um, I hope this final part, I guess the problem with this final part is the fact that is this fact about the version of the web app server I'm using, because I was using 2019 web app server. So I guess that was the problem. Let me make a double check. Let me make a double check. Okay, I'm going to make a folder. I'm going to save this version here. I'm going to copy the other version. I'm going to restart the server. Yeah, that was the problem. I was using an older version of Matlab Web Server. That's why we take this amount of time. That's the reason why. In my first attempt, I used Web App Server 2019. So that was the older version was recognizing as corrupt the 2021 files as corrupt. That was the problem. So I guess right now everything makes sense. Yeah. Now you see that in this case the web application make more sense now. At this point is what we expect to get for each application, where we can change the parameters. We can change any of this. Can modify some. We can make some modifications on the parameters. We can modify the PID controller. We can modify the input signal. I need to add this extra feature, but this is an example of what we want you do. This is like a step-by-step guide how to do it. All these files will be provided to you in order that you can verify that that your installation and everything works. And also you can use this one as reference. Of course, you can change layout and any other things, and each system definitely will have different things and different modeling. This model has all these things. Other models for sure will have other parameters, so keep that in mind. But this is like a good idea of what we expect. Do you have any other questions regarding to this laboratory? Sorry, it's totally the final project. All right, I think not for now. I guess right now I'm going to. I'm going to stop presenting at this moment. If you have any more questions, we will be here up to noon. So if you have questions regarding to your application, to your specific application, please do it. Or if you have question related with your previous lab, also do it. This is the moment to, if you have questions, this is the moment to ask for some guidance.
I had a quick question about like just the deadlines on the assignments
Yes.
for the final project. It's because it says everything you went over right now is essentially what's gonna be due for us next Friday, right?
Except the for next Friday is up to the GUI, not the web deployment. We have, okay, let me open the presentation just to clarify everything.
Yeah, no, because in the first part it's like the model and then the app designer app, but then right
Okay.
below it also says the web app deliverable.
Okay, let me share again my screen. Can you see my screen?
Yes.
Okay. Okay, deadline is here. Next Friday deadline is the multi-physics model, I mean the Simscape and the app. I mean, without compiling the app. Without the web compiler. This is the next Friday deadline. 23 is the compiled app.
Okay.
So I mean, final report is May 5. The web application, it means this, essentially this CTF file. This CTF file is for 23. For next Friday is the multi-physics and the digital twin multi-physics model and the GUI. I mean, the idea is because, as you can see today, I have I face some problems, some last minute problems. Even if, everything was running yesterday and I have a lot of problems today. That's why the deadline is different for the web delivery, the web app part, and the app designer part. That's the reason why you have more time, because depending on your system, you will have to take care of different circumstances.
Okay, yeah, I understand now. So it's just the model and then the GUI design layout that we're gonna be using.
Yeah, and next Friday is the file ready to upload to the server.
The CTF file, right?
Yeah, the CTF file.
Okay, I got it. Thank you for the explanation.
You're welcome. Any other question?
Pyro.
Yes.
I just want to check one more thing. So I'll have to. My project is the cruise control simulation, and so I'll have to develop a regular model like open loop, and as well as and then I'll have two models: a regular open loop model as well as a PID control one.
Yeah, you will have two block diagrams. One is the open loop, and another one is the closed loop with a PID controller.
Okay, and so for the GUI, I'll have to have the inputs control. Can I have like just one set of inputs controlling them both, or will I have separate inputs for each one?
Separate inputs.
Okay, got it. Wait, will I have to include both the Simulink models as well as the two SimScape models I can create?
Yes.
So 4 in total? Okay.
No. If you can create a Simscape model, do with the Simscape model.
Okay.
Not the Simulink. I mean, Simulink is a transfer function.
Yes.
In your case, because I mean the cruise control has the Simscape, do the Simscape instead.
Okay, got it.
if you have class next to this lab, you can disconnect now. See you in office hours or during or next week during the lab. Thank you.